So the agenda for today, we're going to do a bit of an introduction first. We're going to talk about how to create a containerized application, the path that we've taken. We're going to talk about some of the external dependencies that we need to manage for Octopus Cloud. We're going to talk about how we manage our Kubernetes clusters, how we deploy to Octopus Cloud, how we scale our cloud instances, and then a brief mention of some of our future plans. So who are we? So Pawel is the principal software engineer here, looking at the architecture for the cloud and making sure that we're always taking steps towards that. And myself, I'm a senior software engineer on the cloud platform team. But first, a quick disclaimer. So we're going to talk here about our journey from taking Octopus from a self-hosted solution to a cloud solution. So this is going to talk about some of the considerations that were involved in that. It's not a tutorial and it's not a generic recipe for your own applications, but it might give you some inspiration. So I'm sure you're all familiar with Octopus Deploy. Octopus Deploy is a tool for managing and automating your deployments. You may not be quite so familiar with Octopus Cloud. So Octopus Cloud is the hosted service where we host Octopus Deploy on behalf of our customers. We use the term cloud instance to refer to a single instance of Octopus Deploy hosted within our cloud. The beauty of Octopus Cloud is that our customers don't have to worry about the infrastructure that it's running on. They don't have to worry about keeping Octopus Deploy up to date. They can focus on their deployments, and we look after all the details for them. If you want to know more about Octopus Cloud, you can start your free trial at octopus.com. So Octopus Deploy started out as a self-hosted application, and we added cloud support later in its life cycle. So there were a few different steps that we had to go through to make it cloud ready. And the first step was to get it running in a container. Now these days it might seem pretty straightforward to do that. You just right-click on the project in Visual Studio and go add Docker support. But that only gets you part of the way there. There's a few other things that you need to think about when you're building a containerized application. So one of the big things is that we needed to be able to provide all of the configuration up front for the container. So there are various settings that you set up when you're installing Octopus Deploy for the first time, things like the database connection string, the credentials for the first user account, the license key. And we need to make sure that that container already has those details when it starts up. So we needed to make sure that those could be passed in via the command line and environment variables. Now, if you've ever installed Octopus Deploy on a Windows machine, you'll be familiar with this. This is Octopus Manager, and this takes you through those configuration steps, collecting details about the database, what you want to call the instance, the details for the first user account, the license key, those sorts of things. And the interesting thing about this is that if you've gone through and got to the last step, there's a button on there, show script, that shows the command line that it runs to store those settings in your Octopus Deploy instance. So we're using the same technology for self-hosted as we are for our container apps in terms of getting that configuration into Octopus Deploy. There are some other things that you need to think about when you're trying to create a good containerized application. It's easy to create an application and put it in a container, but that doesn't mean that it's doing things to the best of its abilities. So you need to make sure that the application doesn't rely on any special permissions. If you're installed in a self-hosted environment, typically you have privileges to do anything that you might need, like talking directly to hardware and those sorts of things. When you're in a container, that's not always the case. You also want to make sure that the application log goes directly to the console so that it can be viewed with the Kubernetes tooling and piped through to other pods if you've got other pods that are helping ship those logs to other destinations. You want to be careful with your assumptions about networking behavior. So I've got the comment here that there's no place like localhost. So if we were installing Octopus Deploy on a self-hosted instance, it's quite typical that SQL Server would be installed on that same machine. So the database connection would be to localhost. But that's not the case in the cloud. Even if you've got the SQL Server instance running right alongside Octopus Deploy, it's a different network address. So you need to be careful about some of the assumptions that you've made around the networking behavior inside your application. And the other comment I'll make is that you want to try to work with the tooling rather than against it. So a lot of the tutorials for setting up Kubernetes and things will give you patterns that they suggest that you follow, and there are good reasons why they've come up with those patterns. So when we talk about the Octopus deploy container, there are a few other dependencies that it has. So we have the SQL Server database that's storing most of the application data, things like your spaces, your projects, your tenants, the deployment processes themselves. We're also dependent on some file storage. So if you've used the internal package repository, all of those are stored in the file system. There's also archived logs and diagnostic information. And then logging and observability. So we've got real-time logs coming out of Octopus Deploy that we want to keep track of, and we want to monitor the performance of those instances. And then you've probably got external identity providers enabled as well, like Azure AD, Entra ID, or Google Auth. And so those are also required to be set up before we can start that Octopus Deploy container. So in terms of how we implement this, we rely on a lot of the Azure resource types to provide this functionality. So we could host these things directly in Kubernetes if we wanted to, but we're not really in the business of running database servers or running file servers. So we really want to delegate that to Microsoft to worry about. So we use an Azure SQL database for the SQL Server database. We use an Azure file share for the file storage. And we rely on Sumo Logic and Seek for logging and metrics, and then those authentication and authorization providers that I mentioned. So what do we deploy when we're deploying a cloud instance? So we've obviously got the container itself. We've got ingress rules to allow inbound traffic on the web interface, and also for polling tentacles. So polling tentacles use MTLS, so they run on their own port. We also have volume mounts to mount the Azure file share. We define resource limits for CPU and memory use, and we define liveness and startup probes. So those probes typically just involve a web request going to a health check endpoint of the Octopus Deploy application, just to make sure that that Octopus Deploy instance is up and running and healthy. But one of the interesting things to worry about here is the fact that we need to allow more time for startup than we do for the liveness probes. And that's because when we're starting up Octopus Deploy after an upgrade, it can take a wee bit of time to start up if there are database migrations involved. If you've got a lot of data in the database and it needs to transform that into a different layout, then that can take some time. So then we move on to the clusters themselves, the Kubernetes clusters. So again, we rely on Azure Kubernetes Service to deploy and manage the clusters and nodes for us. And we currently deploy clusters in 3 different regions. So we have clusters in the US, Australia, and Europe. Each region that we deploy to contains multiple reefs. And we just use the term reef to refer to a group of cloud instances. Each reef contains multiple Kubernetes clusters, and we make sure that we keep the customer data within their chosen region to reduce any data access latency, and to make sure that we're meeting the data sovereignty requirements for things like GDPR. So this is what that looks like in a more graphical form. So we have an internal tool called Octopus Cloud Portal that's responsible for managing all this infrastructure. And here you can see 2 different Azure regions with a couple of reefs in each region and a couple of cloud instances in each reef. Obviously, the number of cloud instances can differ, but yeah, this is just an example of what it looks like. So then we get on to Kubernetes upgrades. How do we manage the upgrades themselves? So we take the stance that each Kubernetes cluster that we have is ephemeral. So we're quite happy to create new clusters and blow away old clusters. So when we need to upgrade core components, we create brand new empty Kubernetes clusters. We deploy our dependencies inside those clusters, and we get some test workloads up and running to make sure that those clusters are performing well. Once we're confident in those new clusters, we can then start moving customer instances across as soon as those customers reach their maintenance window. The nice thing about this approach is that we've caught a few compatibility issues this way. So we had one recently where there was a change in file locking behavior for our Azure file shares, and that required some configuration changes on our end. And because we had that new cluster and it was running test workloads and we caught that issue there, we were able to stop the rollout of that version of Kubernetes until we had made the necessary configuration changes. So what about alternative paths? Why don't we just have one big, giant global Kubernetes cluster? So the beauty of having these individual clusters is it makes it a lot easier for us to scale our infrastructure. If there's more demand in one region, then we can have a bigger cluster in that region. We can also easily change the size of those clusters on the fly. We can perform gradual rollouts of any infrastructure changes because we can do a single cluster at a time. We also want to make sure that we're reducing the blast radius of any incident. So if something does happen to go wrong, we wouldn't want all of our customers to be offline at once. We'd much rather have a few or no customers offline, hopefully, by only a single cluster being impacted. And if we had one large Kubernetes cluster, it would likely be dependent on core Azure services in a specific region. So if Azure were to have an outage in that region, that could make our entire cloud infrastructure unmanageable. So you might have heard recently about the Octopus Kubernetes agent. We've been using this internally for Octopus Cloud, and this has allowed us to tidy up a few things. So we now no longer require any external access to our clusters. Instead, the clusters reach out to Octopus Deploy to see what deployments need to happen. And some of the deployment steps in our deployment process can now run directly in the cluster as script pods, which allows us to reuse that existing infrastructure that we already have and avoids the need for us to spin up a worker VM. And of course, we use Octopus Deploy to deploy Octopus Deploy. We try to drink our own champagne. So we've got dedicated Octopus Cloud instances that we call hubs that manage the instances for our Octopus Cloud tenants in a particular reef. And those hubs are coordinated by the internal tool that we call Cloud Portal. Cloud Portals will start the deployments on the hubs when a customer's instance is due for an upgrade and within their maintenance window. And so the hubs will go through the process of shutting down the customer's instance, ensuring that all of the required components are upgraded, and then it will push out a new deployment to the appropriate Kubernetes cluster. So then we move on to how do we scale our cloud instances? How do we manage the limited resources that we have? So this is one of the beauties of us using Azure resources here, is that for the external things like the database and the file share, it's quite easy for us to change the tier for those resources independently of the instance itself. So we can quite easily increase or decrease the number of DTUs available for a customer's database. And we do that based on the activity that we see within the database. So if a customer is in the process of doing a lot of deployments, then we'll likely scale up the size of their database to cope with that. And the other thing we can do is we can vertically scale our customer pods. So we can increase or decrease the amount of CPU or memory available to that pod. We can also move our customers around to other clusters. So if you're on a particularly busy cluster and your instance is getting busy as well, then we can move you off to a quieter cluster so that there are more resources available to you. And then if you have a particularly heavy workload, then we can look at actually increasing the size of the nodes in the cluster if you're starting to hit the limits of what a single node can host. So then future plans, how would we like to be deploying Octopus Cloud? So one of the things that we're working on at the moment is the ability to horizontally scale. So we would really like to be able to run multiple pods per cloud instance. This would allow us to avoid the need for maintenance windows, hopefully, because we would be able to have multiple pods running for a single customer, and so individual pods could be stopped and replaced without the customer being impacted. So we're still working on this. It requires a lot of work behind the scenes, mainly in Octopus Deploy itself. So we want to make sure that we don't end up in a situation where deployments are running simultaneously on different pods. We want to make sure that if you've kicked off a deployment, it only happens once. We also want to make sure that those deployments can recover from the Octopus server disappearing and coming back again. And we want to make sure that no matter what happens, every customer is going to see the same view of the world. So we wouldn't want one of your users to see that version 1 was deployed while another user saw version 2 was deployed. We need to make sure that no matter which pod your requests come into, you get the same information back. So as I say, that's ongoing. The cloud is never done, but you can follow our progress at roadmap.octopus.com. And that brings us to the end of the slides.
Awesome stuff. Thank you very much, Carey. Now we'd like to take some time and answer some questions here, if you happen to have any questions. So I know that, Pawel, you answered this question in line, but we just got to show it here. So Michelle asks, do you use auto-scaling in case a customer suddenly start to do a lot of deployments, etc.? So obviously, Octopus Cloud running on Kubernetes, we want to make sure that we're cognizant of the fact that, there's going to be different workloads running all the time with our customers who are hosting. And then you wrote as a response here, Pawel, maybe you want to expound or maybe elaborate on what you were saying here.
Sure. Right now, so Octopus Server right now, it's a stateful application. What we mean by that, it keeps some important state in memory. Kubernetes was designed really for stateless applications. So that creates a bit of a challenge for us when we are scaling. Because obviously when we create new pods or restart pods, we lose very important state. And this is why we are running just single pod for cloud instance. That we recognize that as a significant limitation. So we have a team at Octopus that is actively working on removing that limitation right now.
Awesome. We have another question here that came in from Rahul. Given that database migrations can prolong startup times, have you explored any strategies or optimizations to minimize this delay, particularly during critical deployment windows? So I'm imagining that this is a scenario that comes up a lot with customers where they're running their clusters and startup times can be a little bit more lengthy than, say, starting up a web server. So is there anything that, any advice or any strategies that we have learned running Octopus Cloud that might be able to help?
Yeah, absolutely. So that is one of the key metrics that we look at, is how long it takes for us to do an upgrade of an instance. And there are a number of ways that we manage database migrations. One is the fact that we've recently got changes within the cloud platform to look at whether database migrations are required for that particular upgrade. And if they are, we can scale up the database before we do those migrations. So that way, if you've got a big database, your database will scale up, perform all the migrations, and then scale back down to the normal level again, so that instance isn't offline for very long.
Mm-hmm. I'll add another thing here. We also have considered zero downtime upgrades in the past. We've even written an RFC internally, and it's possible to do, but it adds a massive amount of complexity.
Right.
So right now, our approach described by Carey of throwing money at the problem seems to be there at the sweet spot.
We do have a follow-up from Rahul. He's saying, looking forward for the plan for multiple pods per instance. What are the biggest technical challenges you guys anticipate in ensuring consistency and reliability across pods, especially in preventing redundant deployments? That's a big question.
That's a big question, yeah. The main challenge is, yes, basically what we are doing, we're externalizing the state in memory and moving it to the database. So nothing really, we're not reinventing the wheel here. Ensuring consistency, yeah, it's just your regular database. If there's kind of locking different approaches, but nothing unusual here. Just basically moving the state from memory to database.
Awesome. Michelle's asked a couple of questions here. So, future plans to implement something like a Redis cache to improve performance? Question mark.
I think we've considered Redis, but for what we need right now, that might come for in the future for future features. But for now, we have caching based on, or caching validation based on the database in a few places, and that seems to be working well.
Carey, is there anything you want to add to that?
No.
Okay, perfect. Michelle also asks, how do you handle the Kubernetes upgrades? Do you also spin up a new cluster and move over? So obviously, Kubernetes is not a static target. It's continuing to evolve and update. How do we handle that?
Yeah, so that's what I talked about in the slide deck there, that we do spin up brand new Kubernetes clusters. We deploy our dependencies to them and some test workloads and make sure that they're performing well. And then once we're happy with the state of those new clusters, then we can look at moving custom instances from the old version of Kubernetes onto the new cluster.
Awesome. I wanted to just take a second here and just highlight the fact that we've been doing this for quite a while. I took a dig into the blog archives. The internet is really good at archiving old stuff. So this is our initial announcement around how we implemented this. This was back in 2018. And Jason here talks about how we were implementing this. Now, of course, every launch has its challenges. And this is another update article that we had about a year later from Andrew talking about how we were facing 100K AWS bills. So, we struggle with our own technology from time to time, which is fine. Launching a new platform, it can be a challenge. But if you want to know about everything we've experienced, warts and all, you can certainly find these posts where we've been trying to be very transparent in terms of our approach of talking about this stuff. And this is part of the reason why we decided to do this webinar, so give you guys a sense of how we've been utilizing Kubernetes, etc., the road we've been on, the journey we've been on, in the hope that maybe we have some interesting things to share. So that's been interesting. So just some follow-up questions that I had, just as sort of like kind of tickled my fancy, so to speak. So I wrote down a bunch of these here. So when it comes to monitoring, I know that we use like a variety of tools. There's that slide that you mentioned, Carey, in your presentation where we utilize Sumo and we utilize a bunch of data telemetry, etc. Monitoring observability is a huge sort of area in the Kubernetes space. Can you talk a little bit more about kind of things that the signals we're looking for if things are going wrong? Is there any tooling that we built to kind of notify us? Is there any sort of signals we should watch out for if our cluster is starting to quote unquote misbehave for customers?
Yeah, absolutely. So the main page of Cloud Portal, the home page, if you like, of Cloud Portal, is a series of panels showing metrics from the entire cloud platform system. And so there are some key metrics that we pull up on that, like the amount of database activity that each instance sees, the amount of CPU it's consuming, the amount of memory it's consuming. And when those values hit certain limits, they get highlighted in yellow as a warning. And then if they go too far, then they're in red as a warning. And then we start getting Slack notifications going, hey, this customer's having a bad time. We need to do something about it. And so we're continually keeping an eye on that. And we've often found in our pre-prod environment that's identified issues with particular releases of Octopus Deploy, where there's like a database query that just isn't particularly well optimized, those sorts of things. And so, yeah, we're always keeping an eye on those metrics.
And another one that relates to what I was talking about earlier, our 100K AWS bills. Is there anything that we're monitoring around our costs that we need to be cognizant of?
Yeah, that's just another metric that we look after. One of the nice things with our approach is that a lot of the costs are fixed costs. Because we have the cluster, we've already sort of assigned the VMs to that cluster. And so the cost of that cluster doesn't really change too much from month to month. But yeah, it's more so with the databases and the file storage. Those sorts of things can grow quite quickly sometimes when there are new customers that come on board and they've got a lot of deployments. So yeah, those are the main variable components of our cloud costs.
Pawel's answering questions in the background, typing. I can hear him, and he's already answered this one, but we'll pose it anyway, in case for folks who are watching this after the fact. So I think this is pronounced Thrist. I think I'm sorry if I've mispronounced this. How do you manage the amount of clusters and moving customers over from one to the other? How do you keep track of them all? How do we do it? And Pawel, you answered here briefly. We have a custom piece of software that orchestrates that process. Do you want to elaborate a little bit here?
Sure. So we need an orchestrator that spans multiple clusters of the whole upgrade process, and it's a regular ASP.NET web app that does that implements a pattern called Saga, or long-running business processes, and that's what's responsible for it.
Nice. I noticed that throughout this presentation, we've had to come up with our own custom tooling. Has anything I guess my question is we've been doing this for a while. Kubernetes is a relatively newish space. Is there any tooling that's come on board that we've caught our attention? That'd be really cool to start using, or we've already built that tool, but it would have been awesome if it had been available back in the day.
Yeah, so that's where the Kubernetes agent and the recently announced Kubernetes worker have been particularly helpful to us. So we've been early adopters of those internally and providing feedback to the teams about how to make them better. And they've certainly made our lives easier in terms of reducing the complexity in deploying our clusters.
Awesome. Just as on that note, I'll just mention this briefly. So we recently just posted this blog post. This is available up on our blog. This is at octopus.com/blog. Let me see if I can find the link there. There we go. And Trent here has just recently wrote about auto-scaling Octopus workers using Kubernetes. So this is just posted. It's hot off the press, fresh out of the oven. So this is announcing our new worker available for Kubernetes. If you want to read more about it, you can check it out on our blog. Provides a bit of the background, the motivation as to what we did and why we did it, and how to install it. So it gives you all the sort of, here's everything that you need to know regarding the Kubernetes worker. Anything you guys want to mention about this?
It's just really cool.
Nice. He's a man of few words. I love it. Awesome. We have another question here, just briefly. So Rahul asks again, the adoption of Octopus Kubernetes agent, I think, eliminates the need for external access to your clusters. How do you handle security and the integrity of deployment processes within this new model?
So security is one of those ongoing concerns with the cloud platform. We always want to try to tighten the security within the platform and make sure that we're following best practices, and those best practices change over time. So we're continually reviewing the way that we have our cloud deployed and looking for opportunities to tighten the security.
And I've just been educated on how to pronounce Theis's first name. I apologize for that. I'm sorry. I am a terrible reader and an even worse enunciator. So thank you for that. Cool. So we have we've answered a bunch of questions here. We have a little bit of time left. We're at half an hour here. If you have any questions, feel free to pose them to our chat. We're happy to take them here. We're going to hang out on the stream just for a little bit longer. In the meantime, just want to remind folks of some of the resources that we have available. If you're at all curious, you can check out these resources. We talk a lot about how we support Kubernetes at our landing page, which is at /Kubernetes. If you go there, you'll see a page that looks like this. You can start a trial. You can read more about how we support Kubernetes. I just realized we have to update this page to mention our worker. We don't have that mentioned here. So stuff's, even us, we're shipping too much, I guess. But you can check that out at /Kubernetes. Another resource, of course, is our webinars. So you can check out future webinars coming about. We've got a bunch of stuff that we're going to be talking about here. In addition to that, we also are going to be highlighting our new auto-scaling worker. So this is on September 4th. For those of you who are all curious, you can sign up for this now. And Trent and Kit and others will be talking about our new auto-scaling worker for Kubernetes. This is going to be awesome, so make sure to sign up for that. That's available off of our webinars page. We did mention the homepage for our roadmap, which is at roadmap.octopus.com. This should be your homepage, if not a bookmark. But there you can find out everything that we have under consideration, everything that's planned, as well as everything that's been released. And this includes a subsection for Octopus Cloud. So if you're at all curious, check that out at roadmap.octopus.com. Awesome. A couple more comments here. So Michelle mentions our infrastructure is also 100% Azure. And currently we run Octopus on VMs as 2 nodes and 3 workers with a VM as each. Any benefits to moving over? That is a really big standout. I guess this is a question about, what is the benefit of moving over from a VM to, say, Octopus Cloud in this case, right? They're running Octopus on VMs with 2 nodes and 3 workers. I guess it's because we host it for you and we can help maintain it. So
yeah, exactly. So you wouldn't need to worry about those VMs and keeping them patched. That would be our responsibility as looking after the cloud infrastructure. You also wouldn't need to worry about keeping Octopus Deploy up to date because we roll out upgrades regularly to our cloud customers, and they happen behind the scenes.
I was just going to say, we do roll out our features to the cloud customers typically first, don't we?
Yes, we do.
Yeah, and Chris just jumped in here saying they also get the newness. So there you go. Yeah, we kind of we're not treating it as a canary, but it is sort of a canary-ish, I guess. Some of our newest features get turned on there. I guess that makes sense, right? Because we can we have more control over how those things, like we have a consistent version across that whole spectrum of customers, etc. And of course, Michelle has piped in here and said, well noticed and jealous. So there you go. Michelle has also mentioned here, asking, I do not have the quote unquote tooling Octopus uses. So that what probably need creation. Okay. I'm not sure what that means, but, I guess that, she's saying that, I don't have the same mechanisms of maintaining it that you do. So that might be something to mention there.
Yeah. Again, by moving to cloud, you would be delegating the responsibility for those for that cloud instance to us, and we would worry about the details of keeping it up to date and doing any maintenance work that needs to happen on it. So you don't need to be an Octopus Deploy maintenance expert to look after your instance.
Fantastic. All right. I think we've answered all the questions so far, which is great. Nothing has come in lately here. I mentioned all the resources, so this is me tap dancing just for a few seconds here as to if people are furiously typing away with their questions. Looks like we're getting some good feedback. So thanks, Michelle. Really appreciate your questions. Rahul as well. Thank you very much for your questions. And of course, Thijs as well. I apologize for mispronouncing your name. Awesome. Well, with that, Pawel, Carey, thank you very much. We really appreciate the information. And just as a reminder, folks, we're going to have this available as a recorded webinar up on our YouTube channel. Just search for Octopus Deploy up on YouTube. You'll find it there. You'll also receive an email after this stream is concluded regarding recording of this. You can watch this after the fact. So anyways, Carey, Pawel, thank you very much for your presentation. It was awesome to hear how we're using Kubernetes internally for Octopus Cloud. And thank you all for attending today's webinar. And until next time, happy deployments, everyone. Take care.